We're going to be talking about atmospheric deposition of phosphorus and nitrogen in and around Utah Lake. So, as was previously mentioned, Utah Lake is experiencing some algae bloom problems. Thank you for that wonderful introduction to that. So this presentation we're going to go over our methods, our procedures, and what the problem is, as well as kind of the results. Now, we have to tell you up front that we actually never did perform any work on this project. This is more of a project proposal and more of a research overview than actually us going out and doing it. The project was actually transferred over to the civil engineering department for another grad student to pick up and take off. So we just did a lot of preliminary research, and we put together all this information so that they can have a great head start on this work. So, here you go.
So our purpose, the study of this research project, is to determine if atmospheric deposition of nutrients, such as phosphorus and nitrogen, are concentrated enough to contaminate and cause eutrophication in Utah Lake. So it's a very interesting study. This study, once performed, will assist the Utah Division of Water Quality in understanding whether or not lowering phosphorus levels in tributaries will improve water quality in Utah Lake. Currently, the Utah Division of Water Quality is trying to regulate and minimize the amount of phosphorus deposition into Utah Lake. But our thought, and the reason we're conducting this research, is to determine if atmospheric deposition in the form of dust and rain and snow provides the lake with enough nitrogen and phosphorus to cause eutrophication by itself. Very interesting topic that we're working on. So this is kind of a brief overview of eutrophication, which was previously discussed already. This is a photo from Utah Lake in October of 2014 during an algal bloom. So what happens is there are increased concentrations of nitrogen and phosphorus, which are commonly found in fertilizers, household cleaners, manure, waste, things like that. And this causes blue-green algae to grow rapidly. It also requires an increased or a high level of sunlight. And Utah Lake is a perfect place for algae blooms because it's so shallow and covers a large surface area. So it causes the lake to be nice and warm with all the sunlight during the summer. And all these factors put together cause algal blooms in the lake. And these algal blooms cause dead zones in the lake, prevents recreation, fishing, and is also, as mentioned, blue-green algae is a toxin and can be harmful to humans and animals. There was a report back in 2014 that some dog was swimming in the lake when there was an algal bloom, and the dog came out vomiting and ended up dying. So this is a harmful effect that we're seeing. So we want to talk about the source of the dust and the atmospheric deposition. If we look here, this is a wind speed map at 80 meters of Utah. And if we look over here, this is the severe dry lake bed, kind of over in the west desert area of Utah. There are wind speeds that range from 6 to 10 meters per second. That's a very fast wind speed. If we look at a Google Earth image of Utah, we can see in that same area, it's a desert. Right? Lots of dry exposed dry lake beds. Lots of dust can be picked up from these dry lake beds. Now, if we go back, let's see. If we go back to this slide, if we look up at Utah Lake here next to Provo, there are low wind speeds of about 4 meters per second or less, which would imply that as high wind speeds travel through this area, they pick up high levels of dust, and then as they come towards the Wasatch Front, the wind speeds drop, which would cause high levels of deposition of that dust on and around Utah Lake.
So with our procedures, we would use 4 different sample locations, which we'll show a little bit later in the presentation. And in those sample locations, we would have a wet and dry bucket collector that would collect atmospheric deposition both when it's raining and snowing and heavy or dense fog, high water in the atmosphere. And we'd also collect just dry deposition from the windstorms that come through. With that data, we would then be able to calculate phosphorus and nitrates. We wouldn't have any rain gauges, just due to mechanical difficulties of maintaining them at the site locations. We would use Oregon State has a PRISM data program. I'm not quite sure what PRISM stands for, but it is a really accurate data model that allows you to know precipitation amounts in an area. And Dr. Carling has done some comparison reports between having rain gauges and the PRISM data, especially in the Wasatch region. And they are fairly accurate to each other, so it is pretty consistent. With the PRISM data, there is some variance in alpine regions, but what he has found is that their published variance isn't quite what he's found in his studies. So once we go and collect the samples, we would measure the chemistry. So what we wanted to do with this project is we wanted to follow the National Atmospheric Deposition Program. They are the leading experts in this type of science, and we follow their procedures to eliminate any type of contamination or error with our methods. Right here is a typical site for an NADP collection site. You have your rain gauge with the wind baffling. That way you're able to collect the water as it's blowing maybe horizontally. It breaks up the wind currents. And then you have your dry deposition and your wet deposition. And there's a sensor somewhere around here, an infrared sensor that is able to calculate the amount of water in the air. And once it reaches a certain limit, then it moves this mechanical arm and opens up the wet deposition bucket. So some of the NADP work includes providing concentrations of nutrients as they fall. And so this right here is a nitrate ion concentration map from 2012. And we can see here that Utah, in this map, it's kind of, most likely it's uniform, but in other years we do have a pretty big bullseye right around Utah County where you do have all this dust collecting. So right here we have site 1, 2, 3, and 4 for the proposed project. It would be about a 4-hour drive to collect all 4. We collect on a weekly basis. These buckets cost about $5,000 a piece. The rain gauge is between $500 and $1,000. So with our limited budget, we decided that we would not go this route. But one of the grad students on Dashtop was able to produce a similar bucket of superior quality for about $1,000 using some Arduino electronics and some other parts. So once again, here's part of our methods and the testing. We collect them, and we wouldn't actually do any of our chemistry ourselves. We'd send it to the BYU Environmental Lab and have them all run the samples for consistency as well as for expense. Here is the PRISM data. This is just from February, and so you can see the West Coast has it's been hammered this season. It's had up to 12 to 16 inches of rain just in that 1 month. You can see areas where there's been no rain in February, and we've done fairly well ourselves in Utah.
Okay, so just kind of in conclusion, as a result, we expect to find high enough concentrations of nitrogen and phosphorus in these dust samples to cause eutrophication, even without tributary sources, causing high levels of input of phosphorus and nitrogen into the lake. So even though we are not going to conduct this project ourselves, it got transferred around to the engineering department. We look forward to hearing results about how this project goes and seeing if the atmospheric deposition does play an important role in eutrophication in Utah Lake. Thank you for your time.
lake? Worried about this, or planning some changes?
That's an excellent question. So the funding for this project did come from Matt Randall's sponsor, and I'm not sure, do you know who that is? It's some really
Barton.
So they are aware of this, but from what I know outside of this project is most of the cities gather their drinking water from well water along the east front, or the Wasatch front. And so since that is all groundwater, it wouldn't really be affected that much by this, especially because it'd be filtered before the surface water goes through it.
But I'm not really future but it's greatly affected by the farm.
Yeah.
Sources that probably. And I'm guessing you're not going to get all the farmers and stuff using fertilizer.
Probably not. Well, another thing that I know from doing research for this project is that Utah Lake is saturated with phosphorus before you add all of our contamination to it. And so it's not really, can we get a phosphate-free lake, it's how much do we allow in there. It's already, just from the soils Utah County has, Utah has, it's already going to be naturally phosphorus rich. So really cutting down waste treatment, it might help a little bit, but the lake's already going to have it in there already. So these are going to occur with or without our interaction and intervention.
Time for one more question.
So you showed that map of the wind speeds. I'm wondering if you know anything about prevailing wind directions? Like,
Yeah.
would it even blow up?
Yeah, so if we go back to that, there are papers published. I didn't include any of them, but there are papers published showing a general wind direction that goes from southwest to northeast, which is perfect for our study. Well, not in a good way, but it is pretty strong evidence that this is where the high wind speeds are. That's the dust that's being picked up and then deposited right along the Wasatch Front where the wind can't really travel over the mountains. So it's all just deposited right along the Wasatch Front.
Great, thanks guys.
Thank you.